Hello everyone, this is Arsh Singh Chauhan. We present to you our second ELL 100 assignment through which we explain the basic functioning of a radio receiver circuit. First, let us familiarize ourselves with the EM spectrum. So, as you move on towards the right, the wavelength decreases and the frequency increases. We can see that the FM waves have pretty low frequency and pretty high wavelength. Now, the main point of focus here will be the FM waves, and we don't need to care about the rest right now.
Now, Mr. Kotiya here will start the explanation of the block diagram with the first component of the circuit, that is the antenna.
An antenna receives all EM signals from its surrounding and feed them into the circuit.
Well, that was quick, wasn't it?
Guys, let me now explain the RF amplifier. The RF amp has a pre-select filter which rejects unwanted frequencies and noise and feeds the favorable signals into the circuit. After this, the comprising low noise amplifier amplifies the signal and sends it to the mixer.
The mixer receives two inputs, one of frequency nu1 from the local oscillator and another of nu2 from the low noise amplifier. It gives outputs nu1 plus nu2 and nu1 minus nu2. Nu1 minus nu2, called intermediate frequency, is further fed into the circuit. Nu2 from the oscillator can be changed to tune into different stations. Output of the mixer is the down-converted spectrum of the FM band.
Dude, do you even know what you said?
Of course I do.
Alright, let's move on to IF filters. The IF filter lets only a specific frequency pass through it. It does so by using a series of IF amplifiers and band pass filters. The intermediate frequency is fixed for all circuits, which ensures that the same circuit can be used to demodulate and further process.
The demodulator just converts the encoded electronic signals into audio signals. It recovers the audio and discards the rest of the carrier signals.
Coming to the audio amplifier and the speaker. The audio amplifier amplifies the audio and directs it to the speaker for output. Now, let's understand the automatic frequency control. Also known as automatic frequency tuning, AFC circuits are used in situations where you must accurately control the frequency of an oscillator by some external signal. The AFC circuit senses the difference between the actual oscillator frequency and the frequency that is desired and produces a control voltage proportional to the difference.
Come on people, this is getting really boring now.
Now, I will start explaining the parts of the main circuit.
Wait, you can't ignore me like that.
Watch me. The circuit comprises of 4 parts: tuning circuit, demodulation circuit, audio amplifier, and audio output.
Fine, let me explain the tuning circuit at least then. The tuning circuit comprises of the pre-select filter, low noise amplifier, and the mixer. Its main function is to let pass the selected FM spectrum from the whole EM spectrum. It lets only the selected frequencies pass by, changing the resonance frequency, which depends on the capacitance of the initial part of the circuit.
An FM demodulator circuit comprises of voltage control oscillator, phase comparator, low pass filter, and a source follower which segregates the two parts of the circuit. It converts the electronic signals into audio signals and passes them on to the audio amplifier.
My turn. Oh yeah. The amplifier circuit comprises of a non-inverting operational amplifier. The input voltage is amplified according to the relation AV is equal to 1 plus RF by RV, where AV is the amplification factor and RF and RV are the respective final and initial resistances.
After this, the amplified audio is heard on the speaker.
Finally, let's see how we can tune into our favorite radio channel, 93.5 Red FM. The desired frequency can be set by varying the frequency input nu2 from the local oscillator. As in when we get the desired frequency and the mixer output comes out to be 10.7 MHz, which is the intermediate frequency of the actual radio receiver, we tune into 93.5 FM.
Thank you everyone for your precious time. We do hope you all have learned something new today.